Okay, today we're going to get some practice with VR Vex coding. We're going to start with making a rectangle and then get started on making a pair of parallel lines with a transversal. So let's go to the website first. So we're just going to type in vr.vex.com. And when we get there, you should have a orange when started right here. And our best friends as we try to create things are going to be anything in this blue section and this purple section. So you can either scroll down to the purple, or you can just, if you're at the blue, you could click on the purple and it's going to bring you down there. All the other stuff is if you are a computer science person with a lot of experience, you'll know what a loop is, if thens, if then else, and that can be helpful, but that's not essential to what we're going to do today. So, um, since this is so much fun, we're going to open up our playground. I recommend going to select playground, and you can use really any of these if you want. However, today I would do art canvas as opposed to the grid map. And that's because the art canvas, as you can see, once it loads, the robot is going to be in the center of the screen. So our goal is to tell this robot uh, first, we're going to start with a rectangle just to get our students familiar with the blocks, and then we'll eventually work towards that parallel line and transversal situation. So I'm going to just drag this off to the side. And the first thing I have to do is I have to know how to tell it to move. So if I just drive, okay, if I drive forward and I just press start, I'm just going to keep driving forward forever. I'm never going to stop. So I can actually do one thing better. I can pull this off of here. I can either just like leave it off to the side and it's not going to be used, or I can drag it back to the library over here and just drop it. You hear like a little crunch delete sign. I'm going to go ahead and stop this right here. So I'm going to just drive forward for 200 millimeters. Okay. I'm going to restart using this loop button right there. Press play, and now I'm driving forward for 200 millimeters. If I'm making a rectangle, my next job would be to turn 90 degrees. Now, as I press play again, restart and play, I'm starting to create my rectangle, but I don't see it. That's where we need the purple color. So I'm either going to click the purple, or I'm going to just scroll down to the purple. And there's a couple options you can do. I'm just going to click the move pen. That requires the least amount of clicking around. And I'm going to drag that to the very beginning because I want my pen to be dragging as much anytime I'm moving. So I'm back at the blue. I've gone 200 millimeters, and then I'm going to turn 90 degrees. And if I go 200 millimeters again, what you hopefully will see is that I'm starting to make a square, but we want to give kids practice making a rectangle so they actually have to change some of the stuff in here. So let's just make it 300 millimeters. And then I am kind of obsessive about checking it after each one. I wish I wasn't, but you don't have to check it every single time. So I'm going to turn my 90 degrees again. I want my next side length to be 200 again. I want to turn 90 degrees one more time, and that should be 3 sides of my rectangle. Before we close our rectangle, if you are a little impatient like me, there's a nice little thing you can do. Over here it says set drive velocity. So if we kept it at 50%, that would actually make it go slower, which would be even more painful. So I'm actually going to make it go to 500% so that it goes 5 times as fast. Okay. As you can see, if I were to replay this thing, it's going to go way faster than it did the last time. So I'm going to end with my 300 millimeter side of my rectangle, and then I will be done with my rectangle. Okay. So again, I recommend doing that with your students if they don't have any experience, but you can obviously gauge the experience level of your class and their ability to figure this stuff out. Okay, so I'm just going to pull all of this stuff off to the side here. And now, if you remember, our goal was to create parallel lines with a transversal. So, what I can use out of this is I'm actually going to use the very beginning, the first three, so I don't have to make my life hard. I'm going to set my drive velocity to be fast. I'm going to put my pen down. I'm going to drive forward for 200 millimeters. Now, in the directions I gave, I wanted my students to not pick up the pen again. So if I wanted to make that one of my parallel sides and I still need a transversal, I would probably have to turn all the way around. So I'm going to grab this turn right 90 degrees. But when I say all the way around, hopefully what went off in your head is 180 degrees. And I'm actually going to make this a little bit longer so it's easier to see um, in the tutorial. So now that I've turned 180 degrees, you don't have to come back to the center. I'm going to come back to the center though, and I'm going to drive forward for 200 millimeters. So actually, that's not the center. It'd be 250. Thank you. 250. And so I'm going to restart it. I go 500 millimeters, turn all the way around, and then halfway back to the center. And now, if I want to make a transversal that isn't a perpendicular situation, I'm going to grab my turn again, and I'm just going to turn it, let's say 60. Do it however much you want. I'll do 60. And then hopefully, as we look at this, if I drove, you know, let's just say our transversal is a length of 250. It could be 300. Doesn't really matter. We don't really specify in the instructions. We, you'll see my transversal is created now. Um, so that's the beginning of my transversal. And now, if I want to make that a perpendicular, sorry, if I want to make it a parallel situation, I need to angle back again. So I need to turn, and this is where the whole reason why we're doing this project is for this piece of it right here is for the students to see the relationship between our angles created between parallel lines with a transversal. So hopefully we see that 120 needs to happen there because of its relationship to 60. And now, as you can see, if I drive one more time, I'm going to start to get this uh, parallel line situation more complete. So this is not the final product of what we want. What I am asking my students to do is to create a situation where all 8 angles are shown. So I need to come back with that second parallel line as well as extend my transversal on the outside of those parallel lines. So hopefully you can figure that out. In your teacher instructions, there's a couple examples to get you started if you're stuck. But good luck. Hopefully you have some fun, and it's going to be great.